Section 2A, Adding and Subtracting Radicals. Number 1. When you're adding and subtracting radicals, it's as if you're adding and subtracting variables. So you have to pay very close attention to whether or not you have like terms or not. And the way we decide if we have like terms is the root itself. So if you have two roots that are exactly the same, so in this case, we have a root 2 and a root 2. Therefore, these two terms are considered like terms. So we would approach it as if we had a negative 2x minus 4x, which of course we realize those two are like terms. My point being that we really just add the numerators, or subtract them, or not the numerators, but the coefficients. And in this case we are adding a negative 2 plus a negative 4, or negative 2 minus 4, and we get negative 6. Now we're just adding and subtracting like terms, so the root 2 doesn't change. So we have negative 6 root 2's. If we go further down to number 8, and notice here where we have a situation that has a root 2 and a root 2 again, but then we have a root 5. So the root 2's are considered like terms. So we will look at their numerators, add them. In this case we get 0 root 2's. This is a 1, a negative 1 in front of root 5. There are no other root 5's, so it stays the same. And 0 root 2 is nothing. So root 5 is your simplified answer. It's very important when looking at these questions, before you decide if they're like terms, is to see if the roots themselves are simplified. So we have a root 2, and that is simplified. We have a root 8, which we should see if we can factor or simplify, and I know that I can do a prime factorization of 2, 4, and then 2 and 2. So here's our hockey stick. We're looking for pairs, and they do have a pair. So I can take that pair out. There's a negative 3 already there, so it becomes negative 3 times the 2 I take out, root, and there's a 2 still in there. So this becomes negative 6 root 2. We still have a 2 root 2 on the end that was already simplified. And now we're going to look at the 12. We do a prime factorization there. We have a pair of 2's. We have a negative 1 out front, so it becomes negative 1 times the 2 we take out. And on the inside, we still have a 3. And so this becomes negative 2 when you multiply those two together, root 3. Once we've simplified, we can more clearly see and accurately see which ones are like terms. The last two terms are like terms, so I'm going to take the coefficients and put them together, and we're adding and subtracting, so negative 6 plus 2 is a negative 4 root 2. Again, the root does not change. And we still have our other term, negative 2 root 3.